By the end of this video, you will be able to animate a moving particle between three keyframes or key positions using linear interpolation. That is, the particle will move at a constant velocity for some time, and then it will abruptly change velocity for the remainder of the animation. At the end, we'll briefly discuss a limitation of using linear interpolation to animate. First thing I want you to do is copy in 3 key times and 3 key positions. We're using T for time, which will be measured in seconds, and X for the horizontal position. To type in subscripts into Desmos, you actually don't need to use the subscript button if the subscript is a number. So for T1, you could just literally type in T1. However, if the subscript is a letter like M, you will need to type in T subscript M to get that to happen. We'll do that later. But good. I do want you to use 0 for the first key time and 8 for the third key time because our animation will be exactly 8 seconds long. Whatever you want your middle key time to be is up to you, and then your 3 positions are also up to you. Once you have those, make a list of all your key times, a list of all your key positions, and then type those as a single coordinate, and all 3 of your points should appear. What we're doing here is we're creating what are called keyframes, and this is important to animation. We are telling Desmos when and where we want our particle to be. So I want my particle to be at a horizontal position of 1 at 0 seconds. At 4 seconds, I want its horizontal position to be 3, and at 8 seconds, I want its horizontal position to be 7. Now, how you get between those points can vary from animation to animation. For this one, we're using linear interpolation. We're going to connect them with lines. So that automatically determines what the velocity of the particle has to be so that it makes it to each point at its decided time. So we just use our slope formula. You remember this from high school, y2 minus y1 over x2 minus x1. Use that for the velocity between the first 2 points and the velocity between the second 2 points. Then create a list for those values. Those are going to be useful for us. Now, let me show you what making these lists allow us to do. We can recall values very easily. For example, if I want the second key time, I can just type in capital T bracket 2, and it returns the value 4, which was, if we look up here, that was my second key time. If I want my third position, key position, I would type in X bracket 3, and that's 7. And if I look back up here, sure enough, it was 7. Right, if I want my first velocity, first key velocity, V bracket 1, and it spits out that 0.5. So that recall of values is going to make this very easy. We're going to streamline this. Let me remind you of the formula for a line. Now, this may look a little bit different than what you saw in high school. In high school, you had an M for slope, but here we're using V for velocity, basically the same thing. However, our independent variable here is T instead of X, and our dependent variable is X instead of Y. So if that confuses you, or if you don't remember the point slope or slope intercept, that's fine. Here, just type in what I'm going to type in. You may not understand what I'm typing in here now, but just copy it. It will work. I'm using subscript L for line. And now I'm going to create 2 parameters. The first parameter is K for keyframe. I'm going to tell this function what keyframe I'm starting the line at. And then comma, our second parameter is our independent variable T equals. Now I'm going to tell this function to only connect 2 dots. So to tell it the first dot, I will type in capital T brackets K for our first keyframe. And then we want T to be in between that and the next keyframe. That'll be K plus 1. Brackets. That's a domain restriction, or colon now. Now we type in the function, the line here. We want our velocity first, and that's going to be times T minus the key time, and then plus the key position. And I'm just following that formula on the screen. And there we go. Okay. So again, you may not understand this. That's fine. You type that out. It'll work. Let me show you how to use it. We need 2 of these to connect the first 2 dots and then the second 2 dots. I'm going to call the first line f sub 1 for the first function of t, and now we use the formula that we just wrote out, f sub l, and for k we're going to plug in the first keyframe, just a 1, and then comma t, and there you get a line connecting the first 2 dots. Let's type out the second one, f sub 2 of t. You could probably type this out on your own. Same thing, but here we're just starting at our second keyframe, so put a 2. And there we go. So good, we have both of our lines here. Now they are different colors, meaning they are separate functions defining them. We want this as a single function. So let me teach you how to type out a piecewise function so we can put these together. We're going to type in F sub capital S. I'm going to use capital S here for spline. What we're creating here is called a spline. You can look up what that means. And then of T equals. Now, we only want the first line from the first key time to the second key time. We got to tell Desmos to do this. Now, notice here I'm putting strictly less than. We don't want to define the function twice for time 2. Here, we'll type our first function, our first line. See, we already named it. We already created it. Easy peasy. Comma. Then we're going to go from our second key time to our third key time. We can finish this off with a less than or equal to because our animation will end here. We do want to define it at the third key time, which will, of course, follow our second function that we defined above. So right here, you're going to go to Edit List. And I'm going to change this to blue. It doesn't matter. You can change it to whatever color you want. I just want you to see that it is now one continuous piecewise function. We can go ahead and hide. Don't delete. Just hide the other two. We don't need them. And let's go ahead and pull this. You can click and drag this. You can pull this up all the way to the top. And then let's create a couple more spaces here. Okay. All right, we're getting close. Now I'm going to introduce what I call the main timer or the time control, and that's my T sub M. Remember, you have to actually type in the subscript button for that. And then we're going to start this at 0 equals 0, and we want to go to 8. I told you we would make this animation 8 seconds long, and the step is going to be 0.001. That makes it nice and smooth. Here, you see animation properties. Click that. Change it to play once, and change the speed to 0.5. When the speed of a slider in Desmos is 0.5, the slider lasts exactly 8 seconds long. That's just the way Desmos made this. Now finally, we're going to type out our particle. Our particle is just going to be a point, a coordinate, but the x coordinate is going to be determined by our spline function, capital S, as a function of our main time control here. And then your y coordinate can be whatever you want it to be. If you put 0, it's going to be down here on the axis. I'll put it at 0.5 so we can see it a little bit better. And then also I'm going to go to Edit List here. I'm going to change the color to purple. I just like it. And then we can change the size here. The default is 8. I will make it 15. Done. And we hit play. And here you go. It's going to move from the first key position to the second key position in 4 seconds, and then move from the second to the third in another 4 seconds. And then again, that's because I have my times here at 0, 4, and 8. Now, because it has more distance to travel in the second portion of this, it speeds up, right? It starts off kind of slow here, and then abruptly changes to going faster. But we could change that. We could be more dramatic and make the second key position 2. All I have to do now is change this from 3 to 2, and everything else will calculate automatically. Hit play. It's going to go real slow for the first 4 seconds because it's only going to travel 1 unit, and then boom, it'll take off for the last 4 seconds. Now, it doesn't have to travel forward. You could make your first key position greater than your second, and this will force it to travel backwards for a little bit before it changes velocity and direction and moves forward. So because of the way we set this up, you now have complete freedom to change your key times and your key positions, and the rest will work itself out. Lastly, I said we would discuss a limitation of this. Obviously, the change in velocity doesn't make for a very smooth animation. We don't have smooth transitions at our keyframe, specifically the middle one here. We can see this visually by graphing the velocity function or the derivative of position. All you have to do is type in F sub capital S and put an apostrophe. That means derivative, and the derivative of position is velocity. Parenthesis, for whatever reason, putting a T here doesn't work, but we'll put an X here, and there you go. You get this orange. Yours might be a different color. But here, this is the velocity graph, and we can see that it is very much discontinuous. We have this jump in velocity. And that's just part of using lines. You can't get away with that if you're going to use linear interpolation. So the next video, we're going to remedy this using sinusoidal interpolation, in which we will smooth out the velocity over a keyframe. But anyways, thank you for sticking around. I hope you learned something. Please like and subscribe, and we'll see you in the next one.